All right, guys. I'm up according to our director of streaming, Thomas. And our tester, Lana, saying that we are visible and audible, which is great. So today we have multiple continents involved in this session. So welcome to number, and Elaine here is. Uh, what is not a continent? Africa, Africa, where Tunisia is a continent. So today we have Ahmed live from Tunisia, from one continent. I am on the other continent. I'm actually in a completely different time zone and space-time continuum called Bosnia. We have guys in Maastricht in Netherlands and somewhere in some Asian country called, I don't know, Vietnam, Thailand, something. We have Sam representing Asia. So, why did we join all these people together? Well, we want to show you a very simple thing called translating one sentence from English to Arabic. Typically, what you would do in order to translate, you would find somebody who knows both languages and you would ask that person to translate that for you, and that person will charge you money. Okay, the problem is not when you have one sentence, the problem is when you have hundreds of thousands of these sentences. This is a real problem because we are producing so much content uh, online, and this is just accelerating. So we have more and more content. Uh, some of that content is just entertainment content, but quite a lot of content is scientific, educational content that people need in order to learn the new skills, etc. And this is a big problem because most of that content is generated in English language. And if you don't speak English, you don't understand. You don't have access to all that knowledge, all that data, all that information, how to, etc., etc. So if I am to ask that person to start translating all the content to Arabic and all the other languages that are suffering, that person will quickly just, give up on life, etc., because they just can't keep up. So we need to use AI and other tools, computer tools, to translate English content into these other languages which are not as represented. Uh, and typically, you would go to all these lovely, jubbly AI systems for translation, such as Google Translate and so on. But very soon, you will find out that the translation is just approximate, so it's worse than my English with the pronunciation, with genders, with precision and everything. So you kind of have a gist what they are talking about when you translate the text, but you don't have a precision. Okay, and it's very important to have precise information that is in scientific, educational, and health articles, for example, uh, translated exactly what, so no meaning is lost, When we say labor in English, this word means working class, but also it means that you are having contractions and you are going to deliver a baby. But you have an adverb called laborers, which means that something is you are working very hard. Now, when you translate that into Arabic, you are getting completely different meanings and opposite meanings, and it's very important when you are talking about health information that you get it right, so people know what you are talking about. So what we did here is we tried these Google Translator similar services, and we figured out that they are around 40% accurate. Okay, so yes, I get the meaning roughly, but the accuracy is 40%. So this is why we are doing this project called AIC Hub, where we are translating, first of all, articles from health articles from NHS, National Health Service of UK, which there are around 3,000 of those, describing all the common medical conditions in a relatively simple and understandable way, so people who don't know anything about those conditions can find out what those are, what type of symptoms they are, and what is sort of outcome of those conditions when they need to contact doctors, and so on and so on. So this is what we did. We kind of finished the project. We are just going to publish these apps soon. So what we want to cover today is show you this journey from this sentence, where it starts from till where it ends, and what is our idea how we can increase the accuracy of these translations and so on. So today, as I said, with me, we have Ahmed from Tunisia. So he worked very hard on this project. And Ahmed, maybe you can share your screen and then say hello to these people, and maybe start telling us what is this all about. What was your role in the project? What did you do? What did you accomplish?
Hello. Okay.
Hello, Ahmed.
Hello, Ahmed.
Yes. So, what we did first is we checked the NHS articles. So there is a lot of articles in NHS website, but what we want is we need to get the content of these articles. We need to get the images, we need to get the text, and every other information in these articles. So how we will get these and how we will do this thing. So we noticed, first of all, that in NHS website, there is 4 types of articles, or let me say 4 way to display these articles. The first way, which is the common one, is to be like this acne articles, list of links or related links in the first part, and then the text and the description and etc. The second type, which is just a normal article, just a text, list, etc. And the other 2 types are like list of links. The first one is these boxes, like you can see here, with a link and a small description. And this last one is just a list of links. You click on this and you will be redirected to another article. And of course, that article will be one of these 4 types. So how we will get this, how we will know what's the difference between them, how we will get all this data. That's why we went to the NHS documentation website, which is the NHS API's documentation, which is this one, developer.api.nhs.uk. And we took a look on how we can get this in the fastest way, because as we said, there is a lot of articles in NHS website, a lot. We can execute for each one a separate API. That's why there is this health A to Z, which are the health articles, and they are filtered using the letters, the alphabet letters. And the fastest way is to use this API/category equal to the letter, and by executing this API 26 times with the 26 English alphabet, we can get the list of the articles, only the list. So for example, if we execute this one, we will get all the articles started with the letter A. And this is a JSON object. It's a list of articles started with letter A. We don't get the
Ahmed, are there
okay.
any articles we start with zero, one?
Excuse me?
Are there any articles starting with a number, not letter?
No. This is the filter in NHS website. That's mean when you go to NHS website, you will get this list. When you click on each letter of this, you get the list of articles. This is for health A to Z and also is for the medicines articles. So anything I will say on health A to Z is applicable on medicines. So even, for example, an article start with, I don't know, 0, it will be listed in one of these letters.
Okay.
Okay, so as I said, this is the list of articles, and each article is an object. As you can see, this selected part is only one article's key value. It's a JSON object. So what we care about is the last two keys, which are the URL and the name. The name is the name of the articles, like acne, and the URL is the API you should execute or you should run to get the content of that articles. So what we did in the step 1, we created a database that have just 4 columns: an ID, a name, a letter, and the URL, which what we have at this stage. Also, we have a flag is extracted equal to 0 because at this stage we have just the name, the URL, and the letter. We don't have anything else. We don't have the text itself of this article.
So your first step is to generate the list of all articles.
Yes, only the list. Okay, so when we execute this URL in that JSON object in the Postman, we will get the content of the article. We will get the article itself, the images, the paragraphs, the sentences, everything else. So when we execute this, we get this JSON object, and there is a lot of keys here. So we don't know which one we will need and which one we don't need. For example, there is a key called type, alt type, and for 90% of the articles is medical web page. So this is, for example, an information doesn't help us. It's nothing. Maybe it has a purpose there, but we don't need it. That's why we saved all the top level keys in a database, which is our second stage, step 2. We added all the top level keys as a column, and we put the value as it is. We don't care if it's an array, if it's an object, we just save it. And then after we get that article, so this is done, we executed this API, so the flag is extracted is equal to 1. So any article in our database is extracted equal to 1. That means the API is executed and we got that article. So we got the article acne, for example. But what about causes, diagnosis, treatment, and all the other sub articles there? So when you click on causes, for example, it will display another article, another whole article itself. So what we need to do, for example, we notice that these three types of articles have like a specific value in these keys we extracted here. So for example, this type, there is a column called related links. If it's different than an empty array, and that array, the size of that array is more than one, that means 100% our article will be in this format. Links, then a text. And we can get the article of these links by executing this URL, HTTPS APIs conditions acne/causes. So by executing this, we get the articles of causes. And of course, we do the same thing, the same pattern. We just save the URL, we save the name, which is causes, and at the stage, we save also something else, the parent. This is a sub-article of another article. So we need to know that.
So can I ask a question?
Of course. Yes, please.
You have a list of all articles, and when you go inside each article, you get more articles.
Yes.
Right?
Yes.
Okay. Cool.
Okay. So when I save this acne/causes in this part of the table, so this table and this table are the same. Okay, but in here, I will just save the name causes. I will save the URL. I already have the letter, and of course, I save the parent of this article, and the parent in this case is the main article, which is acne. So here, the acne itself, the main article acne, has another flag called is done equal to 0. What that flag means? So as we said, there is 4 types. So we went through all the database. We check if our related link column have something like this. If not, we check the next thing. The next thing is this thing. Headline is not null. If the column headline is not null, that means the type of the article either in this format or in this format. How we know the difference between these two? We move to the next column, which is called main entity of page, and we check the first child of this column, and we check the name, canonical links or key links. Based on this key, we know which format we have, and based on the format, we know how to handle that article. So here,
okay, Ahmed.
Mm-hmm.
How did you find this out? Did you find this in the documentation, or how did you know that?
That's exactly what I was trying to say. So anyone will see this, he will say, why the name is canonical links? Why we check the name? Why we don't check the type? The type is more like common word to see the type of the articles. But as I said before, 90% of the articles have alt type equal web page element. So we figure out this by testing, by seeing different articles, by doing this again and again and again, and by also saving all the top level keys to see the difference between an article and the other. So there is no documentation about this point. There is nothing actually so you can notice this, but just by doing this again and again and see what's the difference between the examples you put in front of your eyes. So that's it. That's how we figure out that the canonical links is this and the key links is this type. So far, so good?
Oh yeah, just carry on.
Okay. So after, for example, our example acne, we checked the main article. We found that this related links have more than one. So this is our type. We saved this causes, diagnosis, treatment, and complications. So after we do all this, what we need else from this acne article? Nothing. We have it, we have the main article, and we get all the sub articles we have. So is done, the flag is done will equal to 1. Sorry, will equal to 1 after we finish this check. And after that, we have new articles, we have new sub articles, sorry. So we do the step 2, which is this thing. We do the same thing again and again until we finish having normal articles without sublinks.
So how do you do that? How many articles do you have, and how do you do specifically that?
First, we get the main articles. Second, we executed our cron job to extract these main articles.
Okay,
then,
so what's cron job?
Excuse me?
What's a cron job? That's exactly
cron
what
job.
I'm asking.
Yeah. Okay. A cron job is okay. This is we did a cron job session, so you can check the YouTube videos, but I can also explain this by going to the code and tell you that a cron job is a class. First of all, is a class that have a purpose to do things in the background first with stop conditions. So when you execute a cron job, you tell the system, execute me this job every minute, for example, or every month, daily, anything like that, and you give it the script to be executed. So far, so good.
Yeah, so you can't just run this manually for each article. You have to automate it. So you're using cron jobs to execute this automatically every minute, get a new article, process it according to your script, and then go to the next one.
Exactly.
Cool.
Okay. So after we finish all these cron job things, and we get all the articles we want, in the end of the day we got 3,236 articles, and this is including main articles, sub articles, etc., with 3 types: medicines, health A to Z, and live well. So this is the number of articles we have right now. Okay, so right now, what we need to do? What we want to do is we want to translate that article to Arabic. But first of all, we need to check if what we got from the APIs is right or not. That's why we generated an HTML article, and we generate this from the main entity of page column. So the main entity of page column is a big or a huge JSON object that have all the data in that article. It have the paragraphs, the images, etc., etc. So we generated an HTML articles with the HTML tags, like as you can see here, the P tag, the B, etc., etc. And we also got the images using this object. So if there is an image in the article, it will be something like this. And as you can see, there is no difference between iisiha.com, the English version of the article, and nhs.uk. Of course, there is difference between them, like paddings, margin, etc. But the content is the same image, the same list, URL tags, everything is the same. So at the stage, we are sure that our articles are the same as NHS. We got the right data, we got the right format, and everything is okay so far. Right now, we need to translate these articles. How we will do that? We can use the HTML articles we created, which is this column. This is a new column we created. But can we do that really in using the Google Translation APIs? No, we can't. Why? Because if we do something like this, we have two problems. The first problem is the Google API can't accept more than 5,000 characters. So this is the first thing. The second thing, which is the important thing, is this will not be a good translation. This will not give the right meaning, especially if we have the HTML tags in that text itself. That's why we need to translate the same article, but each sentence apart without the HTML tags, like you can see in here. And as I said before, the main entity of page, which is this key, have it's an array of objects. Each object is a paragraph or is a sentence in that thing. If you can see here, acne is a common skin conditions, blah blah, to touch. And this is exactly what this object says. Acne is a common skin condition, blah blah, to touch, with the HTML tags. So what we need to do is to translate exactly the same object, but we translate only the sentences without translating this key position, without translating what dollar type. We keep the skelet, or we keep the object like it is, but we just translate the sentence of the article, nothing else. How we will do that? We did that by this cron job. So this cron job is to translate the articles. First thing we did, we created a list of the HTML tags that we will ignore. We put all the HTML tags here in order to skip it. We want to ignore these, not delete them, just ignore them. Pretend that they are not there. Why? Just in order to extract the sentence itself and translate it using this API translation. API translate. Okay. So if I scroll a bit down here, this is the main part. based on the name of the key, main entity of page, headline, description, caption, and all these are the name of our table, the name of columns of our table. So based on the name of the column, we do our treatment. We either we translate directly, or either we do something else like adding, we strip the tags, or we add sentence to another sentence, etc., etc. In the end, we will get the same article columns with the same architecture, but with translated sentences and paragraphs. As you can see here, the HTML tag's still there. We just added the text a line right because Arabic starts from the right, not from the left. Everything is the same, just we translate the sentence. And this is...
But can I ask a question?
Yes, please.
So in English, what you just said, it goes from left to right.
Yes.
Okay. And let's say I have a sentence, the book is red. Okay. And the word red has a tag B before and after that. So the word red is in bold letters. Yep. So the book is, and then we have bold red. Yep. In Arabic, it's going to be red is the book. It's going to be written other way around because you read from right. Yes?
Yes.
Okay, so the position of the B tag is now different. Correct?
Okay. Okay. So, as I said, what we did is we kept this thing. You see here, we kept all the object as it is. We didn't touch it. And the good thing in here, for example, if you see this text, the HTML tags is in the beginning and the end, and in the end of the sentence. Okay. And something else, if one word is between B tag, it will be more than okay to be translated in the API translation, in the API, the Google API translator. This is the first thing.
Okay.
The second thing, we didn't translate what we generated. We didn't translate this thing. The same script we use to generate this article in English is used to generate the same article in Arabic. The same script, exactly the same script. That's why we didn't find any problem with the HTML tags inside the sentence itself. And this line is the key thing. By executing this strip tags in the text, if it's a text or it's a if it's a caption, we strip the tag and we translate.
Okay.
We put it back, nothing happened, just from English to Arabic. What we get in the end of the day is something like this. For example, if I go to, as you can see here, these are the Arabic letters, exactly like in the NHS website. So if I go to here, English, this is the Arabic and this is the English, exactly the same, because we did nothing different between these two. What we did for English, we did for Arabic, and boom, that's it.
Okay, so you can see that titles, which are H tags, and these lists, which are U, L, and LI, and all those tags, they're all preserved and they are in correct order. So even if I don't understand Arabic, I can see these are the
Exactly.
same text.
Exactly. And
Cool.
this is again, I said this again, this is due to translated only the value of the key and
Okay.
kept the same architecture of the thing. So right now, what we need to do, we have the article in Arabic. So what's next? The next thing is, are we sure that this articles we have right now in Arabic is 100% correct? Is it the translation good enough to be sent to the users and the user can use it safely? So this is something we need to check. That's why we will not display the Arabic article using this article column. We need to separate each word itself. And I mean by each word, even the P tag, this P tag is a separate word. If a word, if a P tag have a space after it, it's a separate word. For example, we have this metadata table right now. Why we need
sorry,
this?
why do we need to
Yes.
split this in the words?
Yes. In order to fix or to allow to the testers to suggest a correction, we need to give them the ability to click or to just give a suggestion for one word. And also, we need this thing to analyze data later. But right now, let me say this. By splitting each article to words, separate words, we have article ID, sentence number, and word number. The combination of these three values make each word specific. Nothing, no duplicate words here, even if it's the same, V, 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 V. We have 4 V in the same sentence, but is not the same word. The article ID, the sentence number, the word number, the combination of these three make each word specific and unique. Okay? Why? Why we need this thing?
So if I have 3,000 articles and I have a word labor 3 times in each article, in this metadata, you will have word labor 9,000 times.
Yes, but the meaning of the word and the sentence can change.
Of course. So each labor is different.
Yes.
Good.
But Google API, 90% of the cases will give you the same translation.
Okay.
That's why we need to know which time the Google give us the good translation and which time it doesn't. That's why we need some testers to test that, some testers that understand Arabic and English to see the right meaning of the sentence and see if the translation is right or not.
But they reading all 3,000 articles.
No, we can create a pattern here, and we can use AI here.
Okay. So Sam is going to cover that. So, but
Yes.
your testers, how many articles do they read?
5 testers, 100 article each, 50 article each. The same 50 article for 5 testers.
So basically, they read 50 articles out of more than 3,000.
Yes.
Okay, so they read like 1%.
Maybe less.
Okay. Carry on, please.
That's it. So after we split the articles into words, we have generated the same article from that metadata table. So this article you are seeing right now is generated from this table metadata.
How?
Because we have the article ID, we have the sentence number, the word number, so it's more than easy to generate the same article again, because we are what we did is we split it based on the spaces, we added the spaces back, and we generate the article back. But right now we added some new tags for JavaScript in order to be able to click on these words, each one by itself. So I want to click on this word, I click on this word. Why? I need to give the testers the ability to give suggestion only for this word, not a sentence, not a paragraph, just a word. So that's it. The testers select the rule, give the suggestion, they can add a comment, and they can submit, and that's it. They can fix what they can fix, and they can suggest a better translation if they notice something wrong.
So we don't have the dictionary, you know. When you think about translation, you will have a dictionary saying the word labor in English, in Arabic it said that. Okay? But what these guys are doing is finding occasional word labor and then suggest whatever is correct version. And sometimes they just ignore it because it is correct. Right?
Yes, and this is the pattern we are trying to find to be applicable to all the other articles.
Okay.
And this is where Sam can explain this better, because she's more aware about this thing.
Well, that's why she's on the call to do exactly that. Okay, so apart from this job, so it was very hard to get all the articles. First, you had to get the list of articles. Then you had to get all the articles. Then you have to strip the sentences and tags, divide them in something that you can translate. Then you translated that. Then you put back all the things that you stripped. And then you chunk it in each word.
Exactly. And then you generate again each word to be again one article.
But what did you do with letters? Because if the letter is A in English, surely in Arabic it's something else. Like alpha, beta, whatever you have.
Even give me an example so I can understand you.
So if the word is acne, and the word is I don't know aneurysm. Okay, there are two words begin with A.
Mm-hmm.
When you translate that in Arabic, they are not beginning with the same letter.
Of course.
Okay. So how did you do that?
And why is that a problem? I just translate it using the API, Google API, and then I get what it returns me. I translate a sentence, not a word. I'm translating a sentence, a whole sentence, not just one word.
Yeah, but if the title is actually,
Mm-hmm.
the first letter is A.
Okay.
And in Arabic, it's not A.
Of course.
Okay.
So if you can see here, there is all the Arabic letters in this list.
Okay.
After we translate all the names, name, where is name?
So you have to translate the names as well.
You see this line? We are translating the name of the article. So if
it's
we
not
have a
just
name,
translating the content of the article, but also the name.
of course, we are translating the name, and after we translate the name of the article, we did this thing. Where is it? We executed this function to extract the first letter of each name. You see here, we are getting the first letter of each name in the table. That's why we can do this filter again. For example, if I click on this thing, all the articles start with this tab.
So Ahmed, what happens if NHS adds a new article or change something in the existing article?
Okay, so let me show you this in order to answer that thing. If I go to Arabic article English, which are the articles we got from the NHS. So there is something, there is a column in here called date modified. Okay. And last review, something called last review or something like that. Anyway, so using this thing, if the NHS article update, for example, an article or add a new article, this will be the date of when they update that article. Okay?
Okay.
So we will create a cron job that will check the list of articles we have and the list of article NHF have in that date. How? I already said that the best and the shortest way to get all the articles is to use this category API thing. So if I execute, for example, this in, I don't know, 1st of January, I will get the list of articles starting with letter A. I already have the database, my database, all the articles starting with the letter A. I can compare them, and I can compare each date of that last reviewed date, or what's called date modified, with mine. If it's not the same, we do the process again. We extract it, we translate it, we generate the article, we split the article to metadata, and we do that again and again and again and again. And of course, by comparing the list I have in my database and the list returned by the NHS API in that date, 1st of January, I can know or I can notice which are the new articles and the updated articles. So this is a cron job will be done later.
So the whole process is automated and it has ability to fix itself, to update the new articles, change the articles which exist, and so on. So you always have the up-to-date version of the articles.
Yes.
That's brilliant because this morning I got email from NHS saying that they added articles about heart. Okay, so basically what it means that this cron job, when it runs at the end of the month, wherever it is, will pick up those and we will get new articles in our website and applications, etc. Okay.
Yep.
Anything else, Mr. Ahmed?
No, nothing else.
Brilliant. Okay, so that was very cool. Thank you for showing this. This you can go on mute now.
Okay.
I think there was a bit of echo from Ahmed, and we are sorry about that. So we'll see how it works with Sam. But what we are going to do is we did the first step. Okay, we translated these articles, we fetched them, we translated them, we got them, which is brilliant. Okay, but they are not precise. Okay, so the translation is not very good. So now we have to figure out how to fix this translation and increase its accuracy and so on. So Sam will tell us everything about that. But before we jump into this bit, we will have a 3-4 minute little break. So in 4 minutes roughly, we'll continue, and then it's all Sam showing us what the hell we did with these articles next. So thanks, Ahmed, and stay tuned for the second part. Thanks, guys. Give him a second. Hopefully he swapped. Lara, can you just let us know when you can actually hear me on the stream and when you can see the Sam's. Lana can hear me, which is very good. Do you see the screen that Sam is sharing at the moment? And you can see. And then, okay, so Sam, back to you. Please maybe just rewind the 30 seconds so people can.
Yeah. Well, small rewind. This is the metadata again. You can see here that we have the tags in the beginning. And this first and second instance in the table are the tags, and they have the code 0, as can be seen on the column on the right. And all the words from there on, they have a code 1, and it is all from the same sentence. So they have article ID 1, sentence number 1, and then the word number increases.
Mm-hmm. Okay.
So this way we can easily reconstruct the sentences and the articles from this metadata. We also have an additional column here that is the status of each word. So when our users click on a word and they propose a suggestion, we need to keep track of that information. And we also want to know whether a specific change has been proposed by multiple people, because that would indicate that we can eventually replace that change. Then we can take that as a correct replacement. So what users actually input, that is the suggestions that we get from them. So we store some information about the user, the original word. So what was the word that they clicked on, and what is the suggestion that they proposed? And then we also store the rule ID. So I will get back to that in the next slide.
Okay.
When users have proposed these suggestions, we also give them some extra information, and these are the recommendations. So they will get some additional sentences, as you can see in the bottom table. And we store for that sentence the suggestion ID. We want to keep track of when did they see that sentence and what is their response to that sentence. So the question that we ask is, can this same word be replaced also in a different context? So now switch to the rules that we're keeping track of. So when users are submitting all this information, we just give them blank slates, propose anything that you want. It's very hard for us to eventually see why did they propose that change. So we figured out a way to already categorize that data. And Ahmed showed you before that we basically put all of these rules in a dropdown, and they can select on the suggestion what mistake belongs to this suggestion. And then we can do some data analysis on that. This very large orange part in the pie chart is rule number 5 that was indicated. Here it says the translation of the words is correct, but not the meaning. So what that means is the words were literally translated, and every word itself has the correct translation, but the whole meaning is lost. And we see that happens quite often, and it is also the hardest rule to fix, because we need our computer to have full understanding of the sentences in order to do that correctly.
But can I ask a question? Okay, because we had 3-4 versions of this and 3-4 versions of testers. And at the beginning, we didn't have any rules. We just said to the people, if you find a word which is wrong, send the suggestion and we'll replace it. Okay. But that's how did we figure out that we need these rules and so on? What was our journey?
So we were getting a lot of information initially, and we are trying to make sense of that ourselves in find these patterns in the data and write these rules that the computer can fix it themselves. But we see a lot of variation in mistakes. One rule will not work for a specific mistake or a specific word, whereas the other one will work. So we need to split all of that. And it would be very easy if our testers are already giving us that information so that we can learn from them and that we don't have to go over that all of that again, because that was that's initially the goal, that we crowdsource all of the input that we need.
Yeah, so if I have a word acne, okay, in English it's very easy, okay, so there's no gender, there's no, is acne feminine or masculine gender, okay, and I know what is very easy to detect plural, acne is, okay, so I add S at the end and it's plural, okay, but when I translate that acne or acnes into Arabic, basically what we discovered is that sometimes there's not just one simple mistake, that there can be multiple different types of errors that Google Translate did here. So sometimes they get the wrong gender, sometimes they get wrong plural singular, sometimes they get wrong prepositions like the and sometimes they mix up the words. Sometimes, so we notice some patterns, right?
Yeah, exactly, and that's a very good point, that there is a lot of overlap in the mistakes. So one word can be wrong in a specific context, in one sentence for a certain reason, but in another context it will be wrong for another reason. And that's something that we have to figure out and to learn, in what context is one word wrong.
And then if you want to fix that word or fix a similar case in some other article where that word repeats, the fixing is not the same if it's plural or singular or feminine or masculine or any other case. You have to apply different fix to it.
Yeah.
Okay.
Yeah. Maybe we have seen that the word was should always be replaced to the word become. That's a possibility. But of course, people made only translations for the ones that were incorrect. There might also be other sentences where the word was is correct. It occurs quite often. So we really have to figure out what is the difference, where is it a mistake, and where can we leave it as it is.
One interesting thing also what happened in the first version, we allowed people to fix the whole sentences. So you had one word suggestion, but then you had people typing, this whole sentence is incorrect, and they would just rewrite the whole sentence. So was that information useful for AI, and could you do something with it?
It is useful to understand what mistakes are we seeing, what should we focus on. But if we are not keeping track of the location of the mistake in a sentence, basically the whole thing becomes useless. You have to go over it again. We cannot analyze that data with the machine.
Yeah, because when we have a word, a combination of two words, they are very likely to repeat in the article. But when you have a whole sentence, that whole sentence is very unlikely that will repeat in exactly that format in the other article, right?
Yeah. So, those occurrences, that is something that we're trying to figure out. So how we need to generalize information. We cannot look only at specific words. We actually have to find a rule that is valid for that word, but also for similar words. And that's something that we want to use machine learning for, so that usually these types of mistakes you cannot figure out with the bare eye. There is a lot going on in the background. So if it's okay, I'll continue now with
Yes,
this
please.
part. Okay. Yes. So first off, we have a lot of these rules that we're talking about. We want to generalize specific information. So we have one rule, feminine and masculine. It very often goes wrong there. A word should be a specific gender, but then it turns out to be the other one. That doesn't mean that in all cases the word in that form is incorrect. It means that in a specific context we are using the wrong gender. If we are looking at Arabic grammar, it is pretty different than what we see in English grammar. So when in the very first line you have a bag, basically we just add one letter to the word. It is not a literal translation. It becomes a completely different word. When you are using an adjective and a noun together, the adjective will always follow the noun that it is connected to. I can go on with a very big list of all the Arabic grammar rules. Basically, we need to learn also from this information. It exists. This is what people are using in order to write correct Arabic. So we need to learn from that, and we want to create rules that do the same, and that include that in our wrong sentences so that it fixes them automatically. But this turns out to be a very difficult task because there are so many exceptions in Arabic. And that's again the same problem. We want to generalize rules. We don't want to be too specific that it fixes only one word, but we don't want it to be too general so that it creates more mistakes than we actually have in the text.
So go back one thing, because you said something very important. Because we are asking people to fix the word. So if the word bag is incorrect, they will send a suggestion. But you said the context, okay? And this is basically what you are talking about, is when you put this word bag or word book inside the sentence with other words, then it gets a context. And then we have to explain to the computer what the context is. Okay, what are the rules? This is why we have those rules, because we are explaining the context, okay, how to recognize the context. And then you have the exceptions as well, because of course it's a live language, so sometimes it's mostly it's that rule, but sometimes it isn't.
Yeah, exactly.
Okay, so the context is extremely important. So they would say bag is wrong, but this is why we have 3,000 words back in that metadata, because each one of them might be in different contexts in relations to other words which are there.
Yeah, and there are actually some rules that we figured out. One very important one is the adjectives and the nouns that are connected. They should follow the same rules for that word. So if the noun is feminine, then we also have to make the adjective feminine. The same counts for this the that you see in red. So in Arabic, the bag becomes you put al in the front. That's the determinative form of that word. And if you have an adjective connected to that, it should also get the. So it will become the green the bag, for example. I hope I say that correctly because my Arabic is not the best, but this is a rule that we have to figure out in what cases do we need to follow that, and in what cases, because of course many exceptions, we can let it go in that context. So all of that combined, we need some additional information, because people that are reading the sentence, they can make these they can immediately see this word is feminine, this word is masculine, based on a number of reasons. Sometimes it is just a feeling for that word. Once you are professional or native in that language, you know these things by heart, but there are actually many rules that are determining the information of that word. We need the gender, we need the part of speech, and that is basically what type of word it is. So we have nouns, adjectives, verbs, all sorts. Then we need the number, and eventually we also need to know, is an adjective connected to another noun in that sentence? And this is where it becomes pretty tricky, because it's in a normal sense the adjective would come right after the noun, but it can also be the case that it is much further in a sentence and it is still connected to that noun. So a lot of things that we have to figure out, that we have to take into account. What you see here is again the metadata, but I extended it with some additional words. First we have here a camel word, then POS is part of speech, so a noun, pronoun, other things. The lemma is the base of a word. So what is the stem?
What's a camel word? Camel word.
Yeah, good naming over here. The camel word, I'm using the camel tools for this one. And you can see the camel word, it really resembles the first word, but it has some of these stripes and the dots on top of it or below it. And basically this is called the diacritization of a word. For simplicity, and very often if you read Arabic texts online, this diacritization is removed. So when we are translating our sentences, Google doesn't provide us with the diacritizations. And hereby a lot of information is lost, actually, because a word with a certain stripes and dots, but with the same base, can have a completely different meaning when we change the stripes, so diacritization. What this camel word column is basically a reconstruction of what is the most likely diacritization form of that word. And therefore it will also have a, this one will have a more specific meaning, the camel word, whereas the normal words will have multiple meanings. If I ask a certain translation, he in some cases cannot tell because there is not enough information.
Okay, and what is a lemma? You said that's some sort of like the root of the word?
Yeah, so the lemma is the base of the word. You see here this first word is in its determinative form, so it has al in front of it, the, and then the lemma, this word is removed. So this information was obtained with these camel tools, as I will show in a minute. And this base information can also be very valuable for afterwards putting it into an algorithm, because then we might have too much information in this one. We can revert it back to the stem, and then we can figure out how it behaves. Yeah, so then it's important to also take that information into account, not just drop what the tool provides us with.
Okay, cool.
And also important to note is that this part of speech, it can really differ a lot. Like this first word, it might have 5 different part of speech in different contexts, but in this context, it behaves as a noun. And then we have the gender of that word, male, female, sometimes indecisive, as here with the bar. And the number can be singular, plural, but it can also be neutral. There are some specific rules in Arabic that if the word doesn't have a plural form, then it will be in a, the adjective will just follow the singular masculine or singular feminine form. So again, exceptions, that's important to take into account. See. So I can show you now the code on how to obtain this additional information. So
Okay.
swap screens here. Okay. This camel tools is open for use. It's in Python. Basically, what it is a disambiguator. So it is a pre-trained model, a maximum likelihood disambiguator. It can analyze a sentence and it outputs the most likely form of that word, and that's very important. That it's an estimator. Most likely output does not mean that it is the correct output. So it will make some mistakes. It acts with a certain accuracy, and I think it is actually impossible to teach a computer how to do that with 100% accuracy at the moment. A lot of research is done in that field, but it's nice that we can use this. It's open for use, and it has an included database. What we do is insert the sentence as a list without punctuation, just a list, and that's easy because we have that already in our metadata. We analyze that sentence. It doesn't look at the previous sentence or the sentence, the next sentence, and it outputs in a list also the diacritist form, part of speech tags, lemmas, genders, and so forth. Right, so that information is stored. Then let's see. What we have is information on each word in the metadata. So we have all our words, we have our article ID, sentence number, that was the metadata. We have all the diacritized forms, estimation of what is the part of speech, and what is the gender, and what is the number, and so forth. That we can use in some kind of algorithm. But then the question is, how do you want to do that? Because this is quite a massive problem that we're attacking. So in order to run an algorithm with this information, we need to put that information in a table that is usable. And then one issue is that each sentence has a different length of words, so we cannot just throw that in and see what comes out. Sometimes one word in English is translated into multiple words in Arabic. We need to figure that out. And if we have certain fixed input for the algorithm, then we can figure out what is the pattern. So how do we fix certain mistakes? What is reoccurring? To hopefully make that a little bit easier.
So let me just ask a question, because if we go back to what we talked with Ahmed, okay, the testers went through 50 articles, okay? You know, those 50 articles, they found the word acute, that is wrong, okay? In one of those 50 articles, acute is wrong. That's their suggestion, right?
Yeah.
Okay, and then when you look at all 3,000 articles, we said that this word acute can appear 5,000, 9,000 times. We don't know, okay? And then in each sentence, you are saying that it can have a different role in a sentence, that word, can have a different gender, but also it's very important to find these connective words. So in your case, you have in this little table word acute, and then next word is repository, and next word is disease. So maybe you can explain to us what is this, why is the first one correct, why is the second one incorrect? Because for me it kind of, and what is next word and what's next word?
Yeah. So first off, it's easiest to start with one word and then build from that solution. So that's what we did here. We started with the word acute because it is occurring quite often in comparison to the other words in the suggestions that we got from the users. So we have one word acute. It has the part of speech of being an adjective, and it is in feminine form. So show you in a bit. I will show you in a bit what that feminine form is. If we then look at the next word, that would be respiratory. So still an adjective. It is also in the feminine form, and then the word after that is disease. So actually, these three words, they belong together. It is acute is not on its own here. It is referring to disease, but not directly, because respiratory is also referring to disease. So in total, we have a set of words: acute respiratory disease. Because disease is a noun and it is in feminine form, we know that the other two words connected to that should also be in feminine form. If acute were to be in masculine form, that would be wrong in this context.
So basically, what you need to do with your algorithms that you are writing is make sure that you find all the related words, and if our user indicated the rule that is incorrect is the gender, then you can check this. Okay, are they following the gender from the original noun that they are connected to?
Yeah.
Cool. Okay.
We, as we mentioned, our testers checked the first 50 articles. So in these 50 articles, we will have some words acute in feminine form and others acute will be masculine form. But we can assume that all of these were correct. They are now correct because people went over it, they checked everything. Some of them, they left it as it is. So that set of the first 50 articles we can use to train a model on that to actually learn. And in theory, we can use that pattern and apply it in the next over 50 articles. One problem here is that not all possible combinations will be made in the first 50 articles. There will still be, that we will see in a moment. If we just follow the rules that we learned here, we will make more mistakes than needed. So to go over that, how it is done from the start, with the tables in mind, we have our metadata, we have some additional information. You can ignore this feminine, masculine columns. Basically, all that information, we want to filter some of that, because now we are, created all of these camel words sentence by sentence. You need that information, but it is not all useful for the word acute. So what I did is filter out all the words acute, appearing in the metadata in these first 50 articles. This word is the word acute in its masculine form, and then this word is in the feminine form. So what is added is this little smiley face. Then we look at the previous words and we want to store that information as well. At the moment, this was well, we chose to look at the previous word and the word before that because we can see that very often they are following each other. Then we obtain a new table. We have one word that is the word of interest. We have the part of speech for that word. We have the gender, the number, and then we have the next word. So let's say this is respiratory, but it can also have different words that follow it. Of these words, we also need the part of speech because we want to know, are we dealing with another adjective? Are we dealing with a noun or other things? And what is the gender and the number of that word? and then we also choose to extract the third word. And for now, this is where we stop, because it would be unlikely for the word to follow even words, yeah, that are further away from it. Okay, so now we have this table, and it's important to know that we want to generalize the structure, right? So we cannot have one row where we look at the next 5 words and another where we have to look at the next 2 words. So we want to have one format and then find patterns in that, because that's how these models, yeah, they require a certain input. Okay, so that's all the information that we need. Then we need to process that information so that it can actually be used by these models. And yeah, one of the rules for these machine learning models is that we cannot use this categorical data. We need to transform this data table. What we do is for each categorical variable, so each possible feature that it can be, we need to make it binary. So from this table that had only whatever it was, 7, 8 columns, we actually extend that one, make it 39 columns, where all possible features for part of speech of the first word, it can be a noun, then it can be a verb, an adjective. We all need to throw that into a column and make it binary. And only then we can use that as yeah, information for the model.
Oh, this is quite cool, because when we think that we started with the NHS website, where you have the article, and it's certain structure, because obviously they like to display their articles in certain structure. We had applied so many of these different changes in a way that we are storing this information, and every time when we need to do something with the machine to display, to be able to click on it, to make a suggestion, we have to apply another transformation, which is then stored in a different format, which makes it easier for machine to apply that specific rule or specific task or specific job, which will make it at the end, what we are trying to do is obviously create that sentence which will be correct, and we have so many of these use cases, which is just amazing. It's so many little steps, and people often ask me, okay, Andre, how do you translate this into Arabic? How do I do that? And it is absolutely complex thing. And when you look at it and you can't think of it, it's impossible. It's impossible to think of the solution at one go. So this is why we go step by step. Okay, let's do it this way, let's do it that way. So we didn't come up with all these tables straight away. On the first planning meeting, Sam said, "Hey, I need this table which will have this in binary format." But when you analyze the problem, try to see the patterns, try to see the rules, try to extract it after a few rounds of testing. This is where we come up and apply these things, try it out, see what accuracy it has, effect on it or nothing, and choose the best solution. So it's quite amazing to see this whole journey. Sorry, Sam, carry on.
Yeah, of course, and I think also, yeah, what is important is that I'm not claiming that this is going to be the best solution. We're now making steps, we're making progress towards a solution, and then we can improve it. So maybe we should not look at the past word and also the word before that. It might need a different structure. But yeah, at least we're getting close to a solution that can be improved over time. So this was the pre-processing of the data so that we can use it in a format for these machine learning models. If we continue now to the actual analysis, so we're still looking at one word acute. We created a data table that is quite extensive. We need to figure out what is our training data. So the training data, as mentioned before, is looking at the first 50 articles, because we assume that this is correct. And then we can apply it for the testing data, which will be the articles that have an ID higher than 50, so they were not checked by the users. Okay, what happens if we throw that into a model? We need to have a target value, and in this case, the target will be is the word in feminine form or in masculine form. And we need to use some models that we can also import. No need to write it ourselves. Okay. Input data, some model training, which we saw before in the machine learning course. It is pretty easy step in code, but a lot is happening in the background. And then we have our first output. Okay, so this is a decision tree. What we want to do is figure out a pattern behind when is a word masculine and when is a word feminine. It appears to be very easy on the data that we initially inserted. So the first 50 articles, and the rule here is the gender of the next word, so the second word feminine, then our word of interest should also be feminine. And that makes sense because in acute respiratory disease, if disease is feminine, then we also need to have a feminine form of the word acute.
Okay.
But this is not sufficient. I went over all the articles in metadata, so all the cases where the word acute occurs, and I checked when is this rule broken. Filtered out these sentences, and I gave them to Ahmed to give me additional information. And that was a bit of data wrangling, going over these models again. Okay, what if we insert all of that additional information? We just get a more detailed tree. And again, this is, for example, one structure that you get. We look at the second word, is it feminine or masculine? Okay, in one case, it just brings up this new decision. So then we look at the word right in front of it. Is it masculine or feminine? Okay. This looks quite complex, but it is actually a very detailed version of all the steps that it can take. And then we can also see how many samples did fall in that category. So for how many samples was this output reached? Now, how is this useful, right? Because we see this pattern, we don't know yet, are there some other options? Do we just need to include more data so that it becomes more extensive, more detailed? Probably that is the case, yeah. So how we can use this is look at how many, what are actually our rare cases here? What do we need more information on? And it's very useful to determine these sentences, and then we can present it back to the user. So that brings me back to, yeah, go ahead.
So basically, for each word acute that appears in articles that people didn't read, you build one of these trees. Is that correct, or?
No, I built a tree on a set of these words acute that are occurring in the metadata, and initially I did it for the words acute that insert in the first 50 articles. So that is our training data, because we don't want to include any wrong, any wrong patterns here, any wrong
So
rows.
those first 50 articles, if every word acute, you know it's correct on the position of that tree.
Yeah. Yeah.
Okay, and then when you run it on other articles that were not tested, so you detect is it correct, incorrect, or somewhere in between.
We're training a model, creating a pattern, and that we need to do on information that we are sure of is correct, because otherwise we're gonna get the garbage tree that basically represents wrong information. So all of this, what you see here, is assumed to be correct, because we trained it on data that we assume is correct.
Okay. So when I get to the word acute 51st article, okay, which obviously we don't know is it correct or not, and you train the model, what happens with that word when you are checking it? What kind of discovery you make on that word?
It is following all the possible options, and whenever a new option is there, it creates a new branch. So initially we had a very small tree. We saw only this this top part, but when we include new information, it's learning more. Okay, in some cases it can show us this structure, and then we can, yeah.
So it keeps adding to that tree.
Yeah, but we have to be careful not to add wrong information, because that would pollute our pattern.
Yeah, so if you just add wrong information, then the tree becomes useless. Okay, so it starts as very correct, and then you add to it. But okay, so how did we go around to make sure that we are only adding the right information to the tree?
Well, at the moment, I just inserted information that we know is correct, but that's an important part that we have to include now. Is we have this preliminary tree with all correct information. Then if a new suggestion is made and it is accepted, so we know that it is, or we assume it is correct, we can add that to the tree. Only if we know that it is correct. And we can use that same structure, or maybe it becomes a new structure, to figure out what are our pain points here. So maybe here we have some endpoint that is quite rare. So we want to know what's up with this one. Can we figure out what information do we need here in order to make our guess more
more likely to be correct. Okay, but this is interesting because we want to finish around 10 minutes because this we are running out of time. But this is an interesting thing what you and me discovered after we ran our second testing group, is that we had a very small number of testers and very small number of articles. So you would expect those testers to give us exactly the same suggestions. So if the word acute in the first article, in the first sentence is incorrect, and you have 3 testers, you would expect all 3 to come up with the same suggestions. Say this is wrong and this should be right. Was that the case, Sam?
Not at all. So there is a lot of variation in mistakes that that testers are indicating. So some people will skip some mistakes. They see it as incorrect. They might give different suggestions for the same mistake, which is not always incorrect, right? We can have synonyms, or just to phrase something slightly differently can be still correct. So we need to come to a consensus, and that's why we also need to steer our testers to a certain direction. We can give them a recommendation, like, look, this is what someone else proposed. Can we say that it is correct, or do you have another solution for this mistake? Yeah, so that's in essence what is included in our program, so that in time it will make itself better, but also the people will make it better. So the more information that is included, the better the recommendations get, and the more secure, with more security, can we say probably this word is incorrect, so please fix it.
Yeah, because so when somebody makes a correction, we can't just take that correction straight away. This is a correct thing. Put it in the tree, okay? Because we have to wait for multiple people to make that same correction, and then we decide to accept that this is actually a true correction. And when you maybe notice when Ahmed was showing part of these suggestions, and you had a slide on it as well, we have the name of the user, okay? Because what we are trying to incentivize people is to give us good suggestions. So what we are doing is scoring the users' suggestions, how good they are, okay? So we are giving them positive points, and we are giving them also negative points. So every time when they make a suggestion, we give them a few points because that's very good. They are helping us. But when the suggestion is accepted, okay, then we give them even more points. So it's not just that they suggested something, that is also we detected that multiple people do that. Same one. So they also, so we are trying to incentivize users to do suggestions, but also to put effort to make them correct. And then we only take those suggestions into account. The suggestions that were incorrect, we kind of don't take into the account. We can ignore them. Okay, so not every suggestion that is given to us through this click on the word is used in this algorithms that Sam is building here, right?
Yep.
Okay. So what's next? Anything else here?
Basically, no. What is next is whenever someone clicks a word, we need to first create that word pattern, check this decision tree, and then get more recommendations, give them back to the user, and that's an iterative process that we want to update.
Yeah. So if I want to recap, okay, so let's say there is a new article, what I asked Ahmed at the end of his lesson was he detects there is a new article, and he can automatically break it down, put all these words and stuff like that, so that's done automatically. And what we would do is automatically use Google Translate to translate it. But then what Sammy has is all these rules that are detected, all the words, all the context relations between them. So even when she gets completely new article or sentence inside, we can straight away apply all these methods, all these models that are developed, all these relationships, and improve even completely new article from 40% accuracy to much higher accuracy, because we are checking what is the gender, what is the relationship between the words, what is the context. We already build up on that. So straight away, new article is much better than the article which we never seen before and just use ordinary Google Translate. But of course, the existing articles, when every time when somebody reads and puts a suggestion, they get refined and get better. So if you read the same article today and read it 3 months later, that article is going to be fixed. And the accuracy, the more people use it, the more suggestions we give, it just gets higher and higher. So imagine, you copy paste part of English and put in Google Translate on the screen, and you have the translation. And just keep it there for 3 months, and that slowly, automatically, just keeps itself refining and gets better and better. So that's what we are trying to achieve here. And of course, we are teaching, in this case, building these models on articles which are medicinal. But if we talk about other articles like mechanical engineer, biology, I don't know, how different, Sam, I know it's very hard to say, but how different you think these methods and these models, how difficult would them to be to adapt to different types of articles in Arabic?
Hopefully not very difficult. Like the underlying structure and the algorithms will remain the same. We just feed it with new information, and then it is trained again, but in the correct context. So it would be pretty easy.
So it would be very relatively easy to get even different types of articles once we get this right. And just to finish it, because this session is expiring in 2 minutes, when we then get another language, okay, if we get another language where you do right to left, we pretty much sorted these kind of rules. If you get another language which has masculine and feminine rules that we have in Arabic, we fix that. But if I say, okay, French or Croatian or any other language which is misrepresented here, some of the rules that we added here are the same. And for the new language, when we introduce new language, we will probably have to figure this out again and add what the rules are different. But the thing is, when you add 5, 6, 8 languages, we pretty much cover all the rules that they are. And then swapping from one type of language to another type of language can be fully automated. And these articles and texts can be generated with a much higher accuracy, and then of course users can click on them and add the stuff, keep fixing them, so the same process applies. They get just better and better as they are being used and so on. Cool. So I think that's it. The meeting has ended. So this sharing of screen. Guys, I just want to thank Sam and Ahmed and Thomas and Lana and everybody who was helping presenting this. I thought it was a very interesting journey, and this is the journey that's not finished. But we thought, okay, can we do something crazy as this? And as Sam said, it's not perfect yet, but we are on the right track. So hopefully, when we release this to the public, to Arabic population, people will start using, making much more suggestions, and these models will get better, 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 and more and more accurate. So I'm just we are aiming to get 99% accuracy on these specific texts. So we'll see how long it will take us, but I think. Some of the stuff that we are doing is already, some of these words that we tested are 70-80% accurate right now, which is quite nice. Well, anyway, thanks everyone for listening. I hope it was interesting. We didn't ask anyone on the stream to ask any questions, so sorry about that. This was more a presentation, just show us what we learned and how we did things. Hopefully it was interesting. Next time we will do something, of course, completely different. We'll talk about view and approaches in programming. How do you approach a programming problem, and what happens if you have a wrong approach, and what happens if you have a right approach. So I think Thomas and we will cover that on a couple of examples, probably on next Thursday. Till then, have a lovely time. Thank you all, and bye-bye.